Hi there, my name is Emmy and I'll be your guide for solving quadratic and cubic equations. You can pause the presentation whenever you need more time to think about something. In the Day 5 model, you learn how to find approximation to a root of a polynomial equation. Rather than finding approximations, however, we would prefer to find the exact roots. In this model, you will learn how to find the exact solutions to quadratic equations and cubic equations that contain some small integer solution. There are formulas that give exact solutions for cubic and quadratic equations, however, these are complex and we will not cover it in this course. There are no formulas for solutions of polynomials of higher degree than 4. Now, for quadratic equations, I hope you recall the quadratic formula. For those that don't remember, here's a recap. If you are given some quadratic equation that has the coefficients a, b, and c, as you see here, then the root, if it exists, can be found by substituting these coefficients into the formula minus b plus minus square root of b squared minus 4ac over 2a. What we see in the square root is called the discriminant. This can help to determine the number of solutions of the quadratic equation. If the discriminant is negative, then there is no real solution. If it is 0, then there is exactly one solution, which is minus b over 2a. If it is positive, there are two distinct real solutions. Now, for the cubic equations, we will look at those only with small integer solutions. To find this integer solution, we can only do so by trial and error. We then factorize a cubic by using long division, which I will show you an example in a minute. We then find the remaining solutions, if it exists, by solving the quadratic factor of the cubic. It might be interesting to remember that cubic equations always have at least one real solution. Let's have a look at an example by what I mean by those steps in the previous slide. Suppose we would like to solve this simple cubic equation. First, we need to find one solution. We do so by substituting some small integers. Remember, we will only present an example that contains small integer solutions. In this case, we will try minus 1, then 0, then 1. Now, substituting minus 1, the function on the left-hand side results in 8, which doesn't equate with 0 on the right-hand side, so this is not a solution. Next, substituting 0 gives 6, so again, this is not a solution. Now, substituting 1 gives 0, which equals to the right-hand side. So 1 is a solution of this cubic equation, and x minus 1 is a factor of the cubic expression. Next, we find the quadratic factor by dividing the cubic expression by x minus 1 using long division. The long division is performed similar to long division you may have done for large integer numbers back in primary school. First, set up your cubic expression and the divisor, in this case the factor x minus 1, in this way that you see here. For the moment, ignore other terms and look at the leading term. Here, in the cubic expression, the leading term is x cubed, and the leading term is x in the divisor. If you divide x cubed by x, you get x squared. Place this x squared on the top. Now, take that x squared and multiply through the divisor. That gives you x cubed minus x squared. Put the result of the multiplication under the cubic expression. To make it easier for you, it is good to line up the same powers of x, one under the other, like you see here. Then subtract this from the cubic expression. Here, the leading term should cancel out at all times. Then, minus 2x squared minus x squared is minus x squared. Minus 5x minus nothing is minus 5x. 6 minus nothing is 6. Or you can simply drop down the minus 5x plus 6. Now we can repeat the process by dividing the leading term of the result of this subtraction by the leading term of the divisor. In this case, we divide minus x squared by x, which gives you minus x. So we write this minus x on the top and multiply the divisor with this minus x. This results in minus x squared plus x. Now we subtract these expressions. Again, the leading terms should cancel each other out. So we subtract x from minus 5x, which gives you minus 6x. And 6 just simply drops down. Again, repeat the process. This time, minus 6x divided by x gives minus 6. So we write minus 6 on the top. And multiply out to get minus 6x plus 6. This time, all the terms cancel each other out, resulting in a remainder of 0. We expect the remainder to be 0 since x minus 1 is a factor of this cubic expression. Hence, we can rewrite this cubic expression x cubed minus 2x squared minus 5x plus 6 as a multiplication of the divisor, that is x minus 1, and the quotient x squared minus x minus 6. Now that we found the quadratic factor, we can use a quadratic formula to find the remaining solutions if it exists. Substituting the corresponding values in the quadratic formula, we find that minus 2 and 3 are solutions as well. So the solutions for this cubic equation are 1, 3, and minus 2. Pause this slide to try solving these cubic equations yourself. The answers are on the next slide. I hope it wasn't too hard. Here are the answers.